Welcome, my name is Terry Soul and this is Programming Chaos, a web channel devoted to interesting programming projects to help you practice your programming skills. For today's project, I'm going to be programming Lindenmayer systems, or LSystems, to generate organic, i.e. plant tree-like structures in both 2 and 3 dimensions. So in a previous video, I should have a link here, I've talked about using LSystems to generate fractal patterns that are less organic looking, and that's one of the common uses for LSystems. Another one is for generating these sort of organic plant-like structures, and that's what I want to focus on in this video. So before we start the code, we sort of have to understand a little bit about the basics of Lindenmayer systems, so I'm going to go over that quickly. The general idea of an L system or a Lindenmayer system is that it's a series of rewrite rules based on a grammar. And by rewrite rules, I mean we have something to start with, what's typically a start symbol like S, and then a rule to rewrite that. So in this case, I'm going to say my start symbol becomes a sort of a stick with a ball on the end. And then we have another rewrite rule that says something like, well, every time you see a ball, rewrite it as a V with new balls on the end. And so this ball becomes a V. And I'm just using these circles here as placeholders to sort of keep track of what should be going on. We might have another rewrite rule that says every time you see a line, replace it with a longer line or maybe with 2 lines. And then we simply continue to apply those rewrite rules. So each of these circles, here and here, becomes their own V, and each of these lines becomes a longer line, and so forth. And you can see from this simple example, we start to get a tree-like structure, or at least a branching structure. So in order to program this, we need to formalize the idea a little bit by writing what's known as a grammar. And so the grammar defines these rewrite rules. So as above, we have a start symbol, and then in this case, I'm going to say a start symbol becomes a forward and a branch, which roughly corresponds to this line is a forward operation, and this circle represents where we would plug in a branch. It's sort of a placeholder. And then our next rule is, well, if you see a B, that should become a left branch, a left, a forward, and another branch. So you can see we've sort of turned to the left, moved forward, and added a branch. And the same thing, but on the right. And then we have another rule if you see an F. So here, replace it with 2 Fs, which is where our short line becomes twice as long. So what we're doing is creating a grammar or a series of rewrite rules that tell us how to expand a string. So we start with a very short string S and expand it like this. S becomes FB using this first rule. The F becomes 2 Fs using my third rule here. The B becomes a left branch and a right branch using this rule, right? So that gives us the left and the right parts. So that gives us a new string, and then we take this string and we expand it just by applying the same rules again. So each of these 2 Fs that we have here double. So now we have 4 forwards, and in a sense, that's the trunk of our tree getting longer. This L and this left bracket remain unchanged. So if I don't have a rule for anything, I'm just going to keep the character the same. This F, based on rule 3, becomes 2 Fs. This B becomes a whole nother branching structure, so a left and a right, and then the same thing. This right is conserved, this forward is doubled, this branch becomes 2 branches. And we could then take all of these rules and use them to expand this string again and again and again. Our structure keeps getting more and more complicated. The nice thing about L systems is the whole structure is defined by, in a sense, a fairly simple set of rules. So by modifying these a little bit, you can get very different structures. Now, in terms of the programming, there's basically 2 pieces that are important. One is we need the rewrite rules that expand our string. So a function that takes a string and expands it. And then another function that can look at a string, like this one here, and follow the instructions. So it sort of says go forward, go forward, go forward, go forward, turn left, go forward a couple of times, turn left, go forward. B maybe doesn't draw anything, so some of these symbols may not draw anything, but that's used to expand the string further, and then we'd have a turn right and so forth. When we do the programming, which I'll start in just a second, there's basically two functions that we need, an expand function and a draw function. So with that in mind, let's tackle the code piece. So I'm going to be doing my programming in Processing, which is available from processing.org if you want to download it and follow along. What I have here is sort of the processing boilerplate to set up and draw images, although of course this doesn't do anything except create a drawing window. In terms of creating the plants, I'm going to do this as a separate class because if we're going to be able to draw one tree, I want to be able to draw a whole forest. So there's my new tab for the class plant. The first thing we are going to need is to define one of our plants is the string that we expand. And so I'll just need as a data member a string. And looking ahead a little bit, I'm going to use S as my start symbol so I can say my string starts with the symbol S. And now I need my expand function that will take that string and apply our grammatical rules to expand it. So I want to take my string and expand it into a new string. So I need a new string. And that new string will start as an empty string. And in order to do the expansion, I need to look at every character in S. So I'm just going to do a for loop to walk over each character in my initial string str. And then for each character, I'm going to use a switch statement to look at the character and decide what should be expanded in the new string. So my first case is my start symbol S. As we saw in the grammar rules earlier, I'm just going to have an S become an FB, a forward branch. So there's the basic idea. Because I saw an S, I add on to my new string FB for forward and branch. And now we can just do the rest of the cases. There we go. So an F becomes two Fs in the new string, and a branch becomes a left branch and a right branch. And the idea, which I mentioned before, is the lowercase l basically is going to say turn to the left. A lowercase r says turn to the right. The square brackets are to keep the branches separate, and I'll have to talk in a minute when we do the draw how they're used in the drawing part. The one other thing we need in our expansion rules is for any other character, like a left or a bracket, we want to keep it unchanged. So that becomes our default case. There we go. So for any character that isn't an S, an F, or a B, that is the default case, we simply take whatever character it was and add it onto the new string. That ends our switch statement. We can end our for loop. And then the last thing we need to do is take this new string and make it the class string. str is equal to that new string. There we go. That's our expand function that takes a string, applies the grammatical rule, and expands them. And hopefully it's pretty easy to see. If we want to make a different kind of a plant structure, we can just go in and change these cases so they match whatever grammar rules you want to have. So that's the expand. The other thing we need is a function that can, given this string, str, figure out how to draw it. So that's going to be our display function. We want to look at each character in the string and based on the character decide what action to take in terms of drawing. So this is the basic structure. We use, again, a for loop to walk through, if you will, every character in the string. And then we use a switch looking at that particular character to decide what to do. And the first one I'll look at is F, which is just forward. So for forward, all I need to do is draw a line from the current location forward whatever amount I want to move. And I'm going to make that a variable, which we can define later. So I'm just drawing a line straight ahead, which is to say in the x direction. So I'm going to use, and we'll see this when we get down to the lefts and the rights, I'm going to use transformation so that the x-axis is always the direction that I want to move along. And similarly, I'm going to keep moving my coordinate system so that 0, 0 is the current location I'm drawing from. And moving the coordinate system, of course, is fairly simple. We simply translate to the end of the line. So I draw a line that's this long, and then I translate to the end of it, and now my new coordinate system is at the end of that line, and whatever I do next starts at 0, 0. So in a sense, all of my drawing is from 0, 0. And then to maybe make this make a little more sense, now we can do the case of an L. Well, if I see an L, my coordinate system is at the end of the current branch. All I have to do is rotate to the left by some angle, and again, I'll define that angle as one of the data members of the class. And then the same thing for right. So we rotate right the other direction. So let's go ahead, as long as I'm here, put in those data members. So I'll make it a float, the length of each section, and oddly enough, I'm going to make that length quite short. And the reason why it's quite short is we have in our rules an f becoming 2f, so we're going to keep growing longer and longer. So I want the base length to be fairly short. So this will, interestingly, not only draw our plants for us, but it'll show them growing. And then for an angle, I'll just use a fraction of pi, right? Pi is 90 degrees. That would be a huge angle for a plant. So I'm going to do a fraction of pi. And these are things, of course, that you can play with. So that takes care of the left and the right and the forward. The other cases that we need to worry about is an S. Well, S is just the start symbol. We don't have to draw an S. B is just a placeholder for where we put in a branch. We don't actually have to worry about drawing anything for a branch. The branches are automatically drawn by our rewrite rule here that handles the left and the right. The thing we do have to worry about a little bit are the left and right brackets. And the way to think about that is when I do a branch, I want to turn left, go forward, and then maybe do some more drawing. And then when I'm done with that drawing, I want to come back to the starting point so I can turn right and go the other way. Well, the way to remember that starting point is to take our current transformation matrix and save it by pushing it onto a stack. And really that is a command that gets used quite a bit if you're doing transformations, which is just our normal push matrix. So what this says is if I see a left bracket, I'm going to go start drawing a branch. I'd better remember where I started by pushing the current transformation matrix onto a stack. And then the symmetrical version of that is if I see a right bracket, that means I'm done drawing the branch and I want to come back. And the way I come back is by popping off the last matrix that I was dealing with. So this effectively says, I've drawn that branch, pop off those transformations to go back to the last one I remembered with my push matrix. And now I can end my switch statements and end my for statement, and I already have my display function finished. So there we go. This is actually all we need to draw at least a simple branching plant structure using an L system. And to make it work, we have to come over here and actually create a plant. I'll ask it to display itself, and then I want it to grow, but I don't want it to grow too much. And so I'm going to call the expand function, but only a certain number of times. As long as the frame count is less than 8, I'm going to ask my plant to expand itself. So it should only expand itself a total of 7 times. That may or may not be enough, but it'll give us a good place to start. In order to watch this happen a little better, I'm going to lower the frame rate. So we'll just see one expansion every frame. And then the last thing I have to do, because all of my plants are drawn from 0, 0, if I were just to start drawing them here, they'd show up in the upper left-hand corner drawn sideways. So I need to rotate and shift my axes so that they get drawn from the bottom of the screen. There we go. So I'm going to, as always, store the current transformation with a push matrix, translate to width times 0.5, so the middle of my window, and height minus 10, so a little above the bottom of the window. And then I'm going to rotate by minus 0.5 pi, so my x-axis will be rotated so it's facing up, and that means my plant will be drawn facing up. And then I can display this, and then I can pop that matrix back off. Let's see what this looks like. So there we go. We can see the plant growing. Each time it gets bigger because each forward is replaced by two forwards. So we had a very teeny plant down at the bottom and it grows bigger and bigger. I didn't put a background in, and so you see all of the old iterations of the plant as it goes. Probably could have gone a little higher here. So let me stop this and make a couple of those changes. I'll have it draw in the background each time. We can try 2 more steps. So little teeny plant, and it grows. Oh, yep, 1 time too many. So this is the basics, and you can see from this we have a nice branching, growing plant-like structure. It's too uniform to really look like a plant, so we should probably put in some randomness. And potentially the stem part, sort of the trunks, are growing faster than we'd like, so we might want to change that as well. So the first thing I want is for each section not to grow quite as rapidly. One way to do that, which I like, is just to make this probabilistic. And I'll show you what I mean. So half the time when we have a forward, we'll replace it with 2 forwards, and the other half the time we won't. So it won't grow quite as much. And if we run this, so our plant starts down here very small, and you can see it's growing, but not quite as rapidly. Some of our branches end up quite short because we don't get very many replacements in them. And this gives us a more natural, sort of organic looking plant. It also means that I can grow for more iterations. So we can come back over here now and set this to, say, 12. And then we can do the same sort of thing with our branching in order to get a more natural look. And I'll do that by changing it so that sometimes we do 2 left and sometimes a little more to the right. And I'll use the same idea of having that occur randomly. There we go. So now 50% of the time the branch will be a little stronger to the left, and the other 50% of the time a little stronger to the right. There we go. And so you can see not so symmetric anymore. It's maybe curving around a little more than I would like. So if that happens, we can go back up here and maybe reduce this angle a bit. And as I said, it can take a fair amount of tweaking to get the forms that you're happy with. There we go. That's not looking too bad. And I think that I'll turn off the frame rate so this runs a little quicker. We won't get to see it grow as much, but things happen a lot faster now. Okay, so we have something that has the right plant-like structure, but it doesn't necessarily look like a plant in the sense of having, say, a thicker trunk or any colors. So the next thing I want to do is add some controls for width of the branches and for the colors. And the way I'm going to do that is by changing my rewrite rules, my grammar, to include some extra instructions. And the basic idea is, if you think about how a tree or most plants work, the main trunk stays a pretty consistent diameter until it branches, and then the 2 branches get smaller. And then it stays a pretty consistent diameter, and then when it branches again, the branches get smaller. This isn't 100% accurate, but it's fairly accurate. And so I'm going to go into my rewrite rules and say, well, When I do a branch, I want to change the dimensions from there, some of the drawing commands. And so I'm going to put in a U, thinking of up. And you can use whatever character you want. And when I finish drawing that branch and come back down, I want to undo that command. So I'll put a D for sort of down as just a way to remember this. A U and a D. So now whenever I do branches, I also know I can use this character to say things like make the next branch narrower, make it a different color. And when I'm done drawing it, I can say undo that command. We could tie it to the left and the right bracket itself, but I like having an extra character instead because it gives us a little more control. So we now are going to have U's and D's in our string, and so we have to add them to our draw rules. So case U, maybe a comment to remind myself this is going up the branch. And what I want to do is make the branch narrower and change the color, but I don't have those variables yet. So before I can actually put anything in here, I need to go up and define some variables to modify. So the first variable is my stroke weight. I'm doing this as lines, so I'm going to make the line thicker in the main trunk with a stroke weight, and then I will modify that stroke weight. And in terms of the color, I'm going to use a hue, saturation, and brightness. So that's going to be the brightness, and I'll start at a low value. So I have a dark trunk and it gets brighter towards the leaves. And I'll start with a hue of 0, which oddly enough will be in red, but it'll be sort of a dark red, which gives us a brownish, which is not terrible for the trunk. As always, these are things you can modify. And so now that I have these, I'm going to use them when I draw the line. The stroke weight for drawing the line, and use my hue and brightness for the color of the line. And for now, I'll leave the saturation as 100. If you want, you can add another variable to change saturation. So this alone will make all the lines look the same, but what I want to do is say when I get to a U and I start drawing a branch, I'm going to change those. So for example, when I branch off to the left or the right, so I make the weight a little smaller. I'm going to crank up the brightness a little bit. And for the hue, I'm going to add 10 to the hue, so I'm working through my color wheel. The color wheel only goes around 360, so I want to do a mod 360. If I go past the end, I'll come back to the beginning. And then the same thing for when we, in a sense, finish a branch and come back down. Basically, I want to undo all of the things I just did. I want to go back to the old values, so I'll just reverse these calculations. So these are simple, just multiply by the inverse. The hue is a little more complicated. Because I'm subtracting 10, I have to worry about going below 0, so I'm going to add 360. And because I'm adding 360, I have to worry about going past the end. So I'll do a modulus 360. And then break, and let's see how this looks. One too many parentheses. There we go. So there's our tree. You can see it growing nicely and branching. And it starts with a thick trunk, but at each branch point it gets thinner and thinner and thinner, and the hue changes and the brightness changes, except that doesn't actually happen because I never changed the color mode. We'll get to that. But the color does change and the thickness changes, and we get a much more realistic looking form. As I said, none of this matches what I described earlier. We're not starting with a dark red because I did forget to change the color mode. So let's go do that. There we go. So hue, which is a color wheel of 360, and then saturation and brightness. I always think of those as 0 to 100. And so there we start, as I promised, with sort of a dark red brownish looking trunk, and it branches out into green. If you like the other colors better, fine, go for it. Right? That part is up to you. And every time we run this, we're going to get a different looking tree because of the randomness in there, but the same basic structure. The next thing I want to do is turn this from a two-dimensional tree into a three-dimensional tree. And so we need to change from a two-dimensional window into a three-dimensional window. Turns out that's pretty easy in processing. We just say I want a 3D window. P3D is all that it takes. And now when I draw this, it looks exactly the same. And the reason it looks exactly the same is because I'm still drawing a 2D shape. I'm not taking advantage of the third dimension. In order to see us sort of taking advantage of the third dimension, what I want to do is start rotating this. So we're going to rotate it so we can see it from all sides. Here I've translated to the bottom of the screen and I've rotated my x-axis so that it is pointing up. And now what I want to do is have the plant rotate around. And that's going to be a rotation, oddly enough, around the x-axis. So now that we're in three dimensions, we got to think about this a little harder. X starts by going across, y comes down, and z, although we haven't worried about it before, comes out of or into the screen. So this rotation here, because we didn't give it a direction, is automatically around z. So I'm taking my x-y axes, x over and y down, and rotating them so x is now up. If I want to rotate my tree, I'm rotating it, notice, around the x-axis. And then we do that just by putting in a command that specifically says rotate around x. By default, this rotation is going to be around the z-axis. How much I rotate, I'm going to again use the frame count to determine how much I rotate by. So I'm going to rotate by a very small fraction of pi based on the frame count. So there we go. There's our tree, kind of in three dimensions. Of course, as I said, when we drew it, we only drew it in 2 dimensions. So it's still a flat tree, but now we can see it rotating around in 3 dimensions. So what we need to do now is change the tree itself so that it's in 3 dimensions. So how do we do that? Well, the approach is when we branch, we don't just want to branch off to the left, we also want to rotate around that direction so our next branches get rotated. And that sounds complicated, but it actually is pretty simple. It just means when I rotate to get a left branch, I also want to rotate around the x-axis. And I'll do another angle, I'll call it angle x, for those rotations. Same thing down here when I branch out to the right. And it turns out these can both be positive because the left is going off to the left and the right is going off to the right, and so rotating by the same amount works fine. And then I just need to come up here and put in that angle. I guess I will make it a data member for the whole class. And I'm going to make that a bigger angle because I want to rotate quite a bit to get my branches to stick out. And I'm making this a data member for the class so that if I create other plant objects, I could potentially go in and change those data members. These are not data members of the class because they're continually changing, right? I keep updating what the weight and the brightness and the hue is, and so I don't want to make those parts of the class. What I might want to make part of the class, I'm not going to, I'll leave it to you if you want to play with it, is these adjustments. So how much the weight changes, how much thinner the branches get, or how much the brightness changes, or how much the hue changes. Those would be good things to make part of the class because then every individual plant object could vary by how much these values change. It wouldn't be bad to have, for example, a starting hue. So not the hue itself, which keeps changing, but the starting hue could be a member of the class. In fact, let me put that in just to show you what I mean. And now when I create more plant objects, I could change this variable so each plant object starts with a different hue. What we're really interested in is looking how this angle x works. So let me put that in. And there we go, there's our tree, and now it's a nice 3-dimensional tree because every time we go out a branch, we rotate before we draw the next branch. And if I run this again, we get a slightly different looking tree because of the randomness in terms of the left and right branches. So this is a starting point. It gives lots of different options for things to play with. It's easy enough if you want a whole forest just to create some more plant objects and display those. If you want, when you create the new plant objects, you can go in and do things like change the starting hue, change the angles they use. So not only do you have a bunch of plants, but you can give each one its own characteristics. One other thing I want to mention is the way that I got the variety out of this was by going in here and putting in some randomness in how the rules are applied. As I mentioned, you could get a similar effect by putting some randomness in here when you rotate your branches. Both of those work. The downside to putting the randomness here is then it is not controlled by the grammar. By putting the randomness in the grammar, it's the grammar that controls the structure. It's very easy, once we have this basic grammar, to expand upon it. If you want, say, a central trunk, you would simply add another option in here, something like just go forward with no left or right turns, and then we'd have a central trunk. If you want other extra cases, so you have a place where there's a branch, but I don't know, you want to put cool things in like knot holes or something, you just add another character that gets added in along the way. So I said this at the beginning and I'll repeat it. The nice thing about LSystems is you can define what your structures look like just by changing the grammar. If you search online under LSystem plants, you'll see all sorts of different grammatical rules that give you different plant structures, or even more fun, at least from my perspective, is just make up some of your own. And in particular, if you come up with any really cool looking structures, please mention the grammars. You can paste the whole grammar rules into the comments below, and the rest of us can try them out. And then one other thing is here I've focused on plant-like structures, and so I've got angles that are good for drawing plants. But you can do things like use 90-degree turns and get weird antenna, more artificial type looking structures, and those can be extremely cool as well. So don't think you have to be limited just to plants. So lots of different structures that you can build using LSystems. Play around with them. If you get anything cool, let us know. Thanks.